You know how kind of out of nowhere our computers and phones got ridiculously good at understanding images? I mean, for years they were clumsy, and then right around 2012, everything changed. It basically kicked off the entire AI revolution we're living in right now. So, what happened? What was the secret sauce that unlocked this incredible new power? Let's dive into the moment AI truly learned to see.
So on the left, you've got the before picture. Computers making these basic, almost funny mistakes, right? Confusing a dog for a cat. But on the right, that's the after. Pinpoint accuracy, identifying objects in really busy scenes without even breaking a sweat. Now, this wasn't some tiny, slow improvement. It was a massive, sudden leap forward. And the big question is, why?
The story really comes to a head at the world's biggest image recognition competition, called ImageNet. For years, the very best systems were stuck with an error rate over 26%. Then, in 2012, a totally new approach didn't just nudge ahead, it absolutely blew the competition out of the water, dropping the error rate to under 16% in a single year. That was the shot heard round the world in the AI community. All right, so to really get this, we're going to start by looking at what caused this sudden leap and uncover the power of going deep. Then, we'll check out the 3 magic ingredients that made it all possible, pinpoint the exact moment it all came together with the AlexNet breakthrough, and finally, see how it kickstarted this whole new era of AI.
The answer to the whole mystery lies in a really simple but honestly profound change in architecture. The neural networks that power AI went from being, well, shallow to being deep. Let's take a look at what that actually means.
So the older neural networks, they usually had just 1 or 2 hidden layers tucked between the input and the output. Because of that, they were pretty limited in how well they could grasp complex patterns. Deep learning, just like the name says, simply means using lots and lots of hidden layers. This lets the network build up its understanding layer by layer, kind of like a hierarchy, learning everything from simple edges to really abstract ideas, all without a human having to tell it what to look for.
So why is having more layers such a game changer? Well, it's all about creating a hierarchy of knowledge. Let's use a simple example to see exactly how this works. This slide just breaks it down beautifully. Imagine you show the network a picture of a cat. The very first layers, they don't see a cat. No way. They just learn to spot primitive little things, simple stuff like diagonal lines, curves, and corners. Then, the next layers take those edges and corners as their input and learn how to combine them into more complex shapes, like an eye or an ear or a whisker. And finally, the highest layers piece all those shapes together to form the final abstract concept of a cat face. That's hierarchical learning, and that is the superpower of deep networks.
And this right here, this is the crucial point. Before deep learning, engineers had to painstakingly, handcraft features. They had to tell the AI exactly what to look for. Look for edges, look for colors. Deep learning just completely flipped that on its head. This whole process is called representation learning. The network figures out for itself what features matter, learning what's important directly from the raw data.
Okay, but this raises a huge question. The basic ideas behind deep neural networks, they'd been around for decades. So if the theory wasn't new, why did the revolution happen in 2012 and not, say, 1992?
What was different? What was the missing piece of the puzzle that finally let these powerful ideas actually work in the real world? Well, it turns out it wasn't just one thing. It was 3 critical ingredients that all came together at the absolute perfect time.
First, you had the algorithm, a technique called backpropagation. Just think of it as a way for the network to learn from its mistakes. It sends feedback backwards through all the layers, telling each one how to adjust itself to get closer to the right answer. Second, you needed the fuel, big data. Datasets like ImageNet provided millions of labeled pictures for the networks to learn from. And third, you needed the engine, GPUs. These powerful chips originally made for video games, they turned out to be the perfect hardware for running the massive calculations that deep learning needs.
And that brings us right back to that 2012 ImageNet competition. This was the exact moment where the algorithm, the fuel, and the engine all came together in one groundbreaking model that would change the course of AI history forever.
That model was called AlexNet, and this quote just captures its impact perfectly. It didn't just win. It proved that this whole deep learning approach was playing on a completely different level.
The numbers really tell the whole story. AlexNet, this deep network with 8 layers trained on GPUs, got an error rate of just 15.2%.
The next best competitor, which used a more traditional, shallow approach, was stuck way back at 26.2%. An 11-point gap in a single year? That was absolutely unheard of. The entire world of computer science sat up and took notice. Deep learning was here, and it was here to stay.
Of course, this overnight success was actually decades in the making. Researchers like Jeffrey Hinton, LeCun, and Yoshua Bengio, people now call them the godfathers of AI, they had championed these ideas through long periods when pretty much everyone else in the field had given up on them. Their persistence laid all the critical groundwork for that 2012 explosion.
The success of AlexNet wasn't just a win for image recognition. No, it was proof of a powerful new recipe for solving all kinds of hard problems. And the ripple effect was immediate and totally transformative.
Once it was proven on images, that same magic combination, many layers, backpropagation, big data, and GPUs, was quickly applied everywhere. It shattered records in speech recognition, it powered a revolution in machine translation, it became the engine behind the recommendation systems we use every single day, and it ultimately paved the way for the large language models we see today. Deep learning became a general-purpose platform for building intelligence.
So, just stacking many layers gave AI its breakthrough moment. But honestly, this was just the beginning. This fundamental idea opened the door to a whole new family of specialized deep learning architectures, each one tailored for different kinds of problems.
In our next explainer, we're going to zoom in on 3 of the most important architectures that were built on this foundation: convolutional neural networks, the undisputed masters of images; recurrent neural networks, the specialists for sequential data like text; and LSTMs, the networks with memory that can understand really complex long-term patterns.
Thank you for watching. Knowledge Equity Partners is a multilingual channel where we share contemporary and practical knowledge on a variety of topics that can enhance your daily lives to make it more effective and efficient.
If you find our content valuable, please subscribe to Knowledge Equity Partners so you'll get notified about our daily videos. Don't forget to like, share, and spread this valuable practical knowledge with your family, friends, and community.
Let's together keep the quest for knowledge always high.
Look out for the next episode for more information.